Welcome back. This is Inc. And in today's problem, we want to determine the RMS voltage across a capacitor. The current through the capacitor is as follow, and the value of the capacitance is as follow. So the first thing we can state is that the voltage current relationship for the capacitor, RV, is equal to 1 over C times the integration of our current with respect to time plus some constant K. Also, our current through the capacitor is the capacitance C times the change in voltage with respect to time. So those are the fundamental equations that describe the voltage current relationship. So for our problem, we want to know that the differentiation of cosine, and we can put 2x just for, let's use t because we're already using t, 2t dt is equal to sine 2t all over 2. So with that said, well, also the RMS voltage is equal to the magnitude of our instantaneous voltage divided by the square root of 2. So normally when we're integrating a cosine function as follow, we do integration by substitution. I'm just going to go through this real quick. So in our case, u is going to represent what's inside our cosine. So u is going to equal to 377 times t. When we differentiate u with respect to time, we then get 377. So therefore, dt is equal to du all over 377. So if we write that out, to get our voltage, we have to differentiate our current and multiply that by 1 over the given capacitance. So that would be 1 over C. And let's just write it as follows. So that would be 10 over C. And our current, and in our current, let's put that 377 T. Well, this time it's U and then du. So we then go ahead and that will be 10 all over 100 microfarads, negative 6 times 377, because du will then take the form of that and we'll move the coefficient out or the constant out. So then we're left with sine, and we change our u or move our, well, replace our u with our value here, our expression, I should say, 377 times t. And then we then go ahead and simplify that. So when we simplify that, we then get 265.3 sine, that is in volts. So that is our voltage across our capacitor. Now to get our RMS, we just had to divide the magnitude or the amplitude of our instantaneous voltage. So we can then go ahead and say the RMS is equal to 265.3 over the square root of 2. And that'll give us 187.6 volts. So the RMS voltage, we take a look at our calculator, the RMS voltage is 187.6 volts. Our magnitude or our amplitude of our instantaneous voltage is 265.3 volts. So before we go, we can then restate that dealing with our capacitor, we want to remember our fundamental expressions that describe the voltage and the current relationship with respect to time. So we then see that the voltage is 1 over capacitance, or 1 over the capacitance of the capacitor, times the integration of the current with respect to time. And we see that the current is the differentiation of the voltage with respect to time multiplied by the capacitance of that capacitor. So that's it for today's video. See you in the next one. Bye.